At 4:17 a.m., coordinated explosions tore through the Smolensk nuclear power plant. In less than 2 minutes, Ukrainian drones transformed a $7.8 billion Russian asset into a burning monument to exposed vulnerability. A cooling tower collapsed, power flickered out across military districts, and elements of Russia's S-400 air defense network failed to prevent the strike, overwhelmed by a threat it was never designed to stop. This wasn't a random act or a lucky hit. It was a calculated response to Russia's latest attacks on Ukraine's power grid, executed at the exact moment Russian commanders believed winter guaranteed their protection. But to understand how 8 drones and 3 partisans reached one of Russia's most heavily defended energy sites, we need to rewind. The operation didn't begin with the explosions. It began the moment Ukrainian planners realized that winter, the same winter Russia always claims as an ally, could be turned into a weapon. Heavy snowfall, freezing winds, and low visibility became tools instead of obstacles. Analysts later termed the method snow jamming. More on that shortly. At 1:09 a.m. on February 18th, 2025, the 368-mile journey began from a concealed airbase near Chernihiv. 8 AN-196 Liuti long-range drones, 6 strike, 2 decoy ECM, lifted into the darkness and leveled off at around 100 feet. That low altitude kept them below the radar horizon, using the curvature of the Earth as a natural shield. Each drone carried a 165-pound incendiary warhead, capable of burning at more than 2,000 degrees Fahrenheit. And each relied on advanced American-developed AI paired with a satellite link, highly resistant to jamming. But the mission depended just as much on the 3 partisans hidden in the Desna forest, positioned with line of sight to plant perimeter emitters. They supplied real-time updates on the positions of Russia's Pantsir S-1 mobile air defense units, the final line of protection for the Smolensk plant. Then the mission met its first major threat. A brutal 20-mile-per-hour crosswind pushed the swarm 3.6 degrees off course. Over hundreds of miles, that error was mission-killing. For most drones, the operation would have ended, but the Liuti's AI simply adjusted. Thousands of micro-corrections pulled the formation back into perfect alignment. In Kyiv, the operator monitoring the telemetry saw everything functioning flawlessly, until one icon switched from green to red. Drone 7, one of the primary strike assets, lost its data feed. Failsafes shifted Drone 7 to autonomous navigation on the partisan beacon, removing it from primary strike assignments. As the swarm entered the S-400's engagement envelope, the 92 N6E Gravestone radar activated. This system can track 300 targets at once. It detected the incoming drones within seconds. A 40 N6 missile launched at high velocity and destroyed a decoy target, revealing reaction time and engagement doctrine. Russian operators recorded the kill and breathed a brief sigh of relief. But it was the kill they were supposed to get. The drone that died was a decoy, built to attract a missile and reveal the system's reaction time. The remaining drones shifted into their next programmed phase. They executed erratic zigzags through heavy snowfall. Ukraine wasn't trying to hide the drones with stealth coatings, they used the snow itself. Low-frequency interference was broadcast into the snowfield, creating widespread radar backscatter. The result was a chaotic picture the S-400 couldn't pass. Its screen filled with meaningless flashes, ghost tracks, and intermittent signals. Low-frequency interference scattered through heavy snow generated backscatter and ghost tracks, a tactic later termed snow jamming. Russian commanders struck back with their own electronic weapon. The Krasuka 4 jammer, operating from roughly 186 miles away, blasted an overpowering jamming wave across the region. It was designed to collapse radio links and fry drone controls. Any conventional drone would have dropped instantly. But the Liuti wasn't relying on radio commands. It was connected to the Starlink satellite network. The ground barrage targeted line-of-sight control bands, while the drones rode a spread-spectrum satellite hop. At that moment, the partisans made their critical move. They planted an explosive at a secondary radar station and detonated it, severing a link to the main grid. In the chaos, they activated a ground-based beacon. A low probability of intercept directional beacon provided pinpoint location data. independent of GPS. It became the fallback navigation system the drones needed to continue their attack. Meanwhile, smoke from the destroyed decoy drifted across the swarm's path. It blinded the drone's optical sensors. 2 drones drifted off course as they tried to recalibrate. Then, the Russian commander escalated again. He ordered a full-power, sector-wide Krasokar blast. For 30 seconds, every mission console for the operation in Kyiv went black. Telemetry died. Video feeds vanished. The drones were alone. But that scenario had been anticipated during development. The AN-196's AI, trained on more than 10,000 simulated flights, took full control. It ignored corrupted signals, locked onto the partisan beacon, and recalculated the attack run in less than a second. When the feed returned in Kyiv, the operator saw Russia's final response unfolding. 2 Su-35 fighters were racing towards the engagement zone at Mach 2. Against slow drones, this should have been a massacre. But the drones dropped in altitude. They dropped to river surface height, using the banks and channel to mask look-down radar. The jets thundered overhead, unable to acquire a lock. Down in the command bunker, the Russian commander stared at screens that told him nothing. His billion-dollar shield was effectively blind. His electronic attacks had failed, and the drones he could no longer see were closing in. When the swarm emerged from the river channel, only 4 of the 6 strike drones remained. They accelerated into their terminal attack formation. Through the camera feed of the lead drone, the Smolensk cooling tower filled the frame, a 500-foot concrete cylinder previously flagged as outdated in independent assessments. Unlike modern Western facilities, it had no reinforced containment dome. It was a non-containment structure essential to heat rejection. Its failure stresses, but does not breach reactor containment. One Pantsir crew managed to fire a final missile using optical tracking. The shot hit Drone 6, destroying it in a violent blast. But the remaining 3 drones didn't break formation. They adjusted and continued. The last moments were brutally precise. At 12 seconds to impact, the drones shifted their angle. At 8 seconds, the tower consumed the frame. At 3 seconds, cracks in the concrete were visible. Then, the warheads hit. The first drone struck 3 feet from the central axis of the main water ventilation shaft. The next 2 hit different structural points along the same entry vector. Impact sensing delay fuses triggered detonation 0.8 seconds after penetration. That delay allowed them to punch through the 2-foot-thick concrete wall before exploding inside. The blasts generated an internal pressure wave above 10 psi. With no escape, the shockwave bounced repeatedly within the tower. The structure couldn't withstand the trapped force. Pipes essential to the cooling system were vaporized. Unit 3's turbine bearing temperatures spiked beyond safe limits. Protection systems tripped the turbine while the reactor scrammed to cold shutdown. Automatic systems executed an emergency cold shutdown. There was no radioactive leak. Containment integrity remained nominal. But 1 gigawatt of power vanished from the grid. 500,000 homes and military sites lost power instantly. The immediate physical damage was estimated at $150 million, but the strategic shockwave was far greater. For 72 hours, Russia's S-400 batteries along the Western Front were severely degraded. Regional S-400 coverage degraded as substation outages forced generator rotations, reducing radar duty cycles for approximately 72 hours. During that window, Ukraine increased pressure across 8 separate fronts, turning Russian defense into a reactive scramble. The economic fallout spread quickly. The Smolensk plant supplied electricity to Belarus. With 1 reactor's output gone, Russia cut 20% of its export supply. That loss cost Moscow roughly $50 million per day, based on corridor capacity and spot prices. It also strained a politically crucial alliance. Inside the Kremlin, reports claimed Vladimir Putin demanded an answer to a humiliating question. How could 8 drones and 3 men in a forest do this? The explanation pointed to a flaw baked into Russia's strategic assumptions. The S-400 was designed to counter bombers and fast aircraft, not drones flying low, adjusting dynamically, and using weather as a weapon. The cooling tower was built in an era that didn't anticipate precision strike drones. The reliance on a centralized grid created a single point of failure. And Russia's belief that winter guaranteed safety ignored the possibility that snow could be transformed into an electronic warfare amplifier. The outcome wasn't determined by which side had the most expensive hardware. It was determined which side understood the battlefield better. Ukraine turned falling snow into a tactical advantage and used low-cost drones guided by high-end AI to defeat one of the most expensive air defense systems on Earth. It was a demonstration of the new reality of warfare. Disruptive ideas can outweigh raw power. The lingering question is simple. If 8 drones could blind an entire region, what happens when Ukraine deploys hundreds? Subscribe to follow our next analysis.